Assalamualaikum warahmatullahi wabarakatuh and good afternoon to everyone. My name is Muhammad Arif bin Azmi and I am from DKA 4B. My matrix number is 11 DKA 19F1034. Okay, so in hydropower plants, turbines are utilized to generate electricity. These water turbines rotate due to reaction force produced when one or more water jets are directed tangentially on two vanes or buckets that are fastened to the rim of the turbine disc. The impact of the water on the vanes generates a torque on the wheel, causing it to rotate and to generate electricity. The study of this reaction force, which is the application of conservation of momentum principle, is an essential step in the subject of mechanics of fluids and hydraulic machinery. The objective of this experiment is to investigate the reaction force produced by the change in momentum of a fluid flow as a jet of water striking a flat plate or curved surfaces and compare the results with the computed momentum flow rate in the jet. The apparatus for the study of momentum of a fluid flow is the impact of jet apparatus. Water enters a cylinder vertically through a nozzle and then strikes a target mounted on a stem. A weight pen mounted at the top of the stem allows the force of the water to be counterbalanced by applied masses. Water issues from the nozzle and after striking the target plate leaves through the outlet holes in the base of the cylinder. The vertical force on the target plate is measured by adding weight to the weight pen until the mark on the weight pen corresponds with the level gauge. Remove the top plate and transparent cylinder from the equipment and check and record the exit diameter of the nozzle. Screw the 90-degree deflect. Connect the inlet tube to the bench quick release connector. Replace the top plate on the transparent tank but do not fit the 3 knot nuts. Using the spirit level attached to the top, level the transparent tank by adjusting the fit. Replace the 3 knot nuts, then tighten in sequence to retain the top plate level indicated by the spirit level. Do not over tighten the knot nuts as this will damage the top plate. The nuts should only be tightened enough to level the plate. With no weight on the weight pen, adjust the height of the level gauge until it aligns with the datum line on the weight pen. Check that the position is correct by gently oscillating the pen. Place a mass of about 50 grams on the weight pen and open the bench valve to produce a flow. Open the flow valve slowly and allow it to impinge upon the target until the datum line on the weight pen is level with the gauge and leave flow constant. Observe and note the flow behavior during the test. Now measure using the volumetric tank. This is achieved by closing the ball valve and measuring the time taken to accumulate a known volume of fluid in the tank as measured from the sight glass. Repeat the procedure by adding an additional 50 grams each time until a maximum weight of 500 grams is reached. Then repeat the whole test for each of the other flow deflectors. To change the target plate, undo the knot screws on the top plate and remove this from the transparent tank. Take care not to over-tighten the knot screws when replacing the top plate as this can damage the plate. When finished taking readings, replace the deflector back to the first one used. Be sure to clean up your station and any water that may have spilled following the lab manual. Complete the results table and put together your lab report. Thank you. Okay, so the data is given for measured values for flat plate. The force already given and the measuring time is given, and we must calculate to get an average measuring time and flow rate. Okay, In the data given, they have 3 values for measuring time, and if we want to get the average measuring time, we must add on the 3 values given and divide by 3, because they have 3 values given. Okay, the average measuring time is unit in second, and the flow rate unit is meter cube per second. Okay, so if we want to get the flow rate, we must convert the measure value that have given in the data, which is liter, and we must convert the liter to meter to get the flow rate. Okay, the next one is data for measured values for hemisphere that have 180-degree deflection. Okay, so same like the flat plate calculation, that they have given the force, the measuring time, and we must calculate for average measuring time and flow rate. And same like the flat plate, the data given for measuring time is 3 values, and if we want to get the average measuring time in second, we must add on the 3 values given and divide by 3. Same like flow rate, if we want to get the flow rate, we must calculate meter cube per second. Then we must convert the measured volume given, liter, to meter. This one for the data for measured values for cone that have 135-degree deflection, and the calculation is same like the both, that which is the flat plate and hemisphere calculation. So now I want to explain about the calculation for measurement values for flat plate. Average measuring time is 38.87 plus 39.04 plus 39.20 divided by 3, and we got 39 seconds. And for the flow rate, we have 0.005 divided by 39. The 0.05 is get from data given, which is the 5 liter, and we must convert from liter to meter, and we get the 0.05. And the answer for flow rate is 1.28 times 10 power of -4 meter cube per second. And the result for flat plate is the velocity is in meter per second, and the formula is V equals to Q over A. And the Q over A is, and the Q is for the flow rate 1.28 times 10 power -4. And the A, how to get the A is we must use the formula, which is the pi d square over 4, and the diameter is given is 0.008, and we will get the answer is 5.03 times 10 power of -5 meter square. And we can go through the velocity calculation. 1.28 times times 10 power of -4 divide by 5.03 times 10 power of -5, and equals to 2.54 meter per second. Okay, and the calculated force, fifth in Newton, is equals to 1000 times 1.28 times 10 power of -4 times 2.54, and equals to 0.33 Newton. So next, I want to explain about the calculation for measurement values for hemisphere. Average measuring time is 48.88 plus 53.18 plus 62.41 divided by 3, and we got the second is 18.27 second. And for the flow rate is Q equals to 0.005 divided by 18.27, and for flow rate we get the answer is 2.74 times 10 power of -4, And the result for hemisphere is velocity. A is 5.03 times 10 power of negative 5 meter square. And V formula is Q per A. Q is flow rate, which is 2.74 times 10 power of negative 4, and divided by A, which is 5.03 times 10 power of negative 5, and we get for the velocity is 5.45 meter per second. Calculation force fifth equals to PQ 2V, and for P we have 1000, for Q we have 2.74 times 10 power of negative 4, and for the 2V is we must 2 times velocity, which is 5.45 and equals to 2.99 N, which is Newton. And calculated force fifth in Newton for hemisphere equals to P times Q times 2V dot, and for the P we have 1016 times 9.26 times 10 power of negative 5 times 2, open bracket 1.84, and close bracket we get 0.34 N. And the third calculation is calculated force fifth in Newton. PQV open bracket 1 plus cos square infinity close bracket, and equals to 1000 times 6.1 times 10 power of negative 5 times 1.21 open bracket 1 plus cos square 135 degree and close bracket, and the answer is 0.02 Newton. Last one, I want to explain about the calculation of measurement values for cone. Average measuring time is 82.2 plus 82.8 plus 83.4 divided by 3, and the answer we get 82.8 second. And for the flow rate is 0.005 divided by 82.8, and the answer we get 6.04 times 10 power of negative 5. And the result for cone is velocity A equals to 5.03 times 10 power of negative 5 meters square, and velocity is 6.04 times 10 power of negative 5 meter cube per second. So we get the answer for velocity is 1.2 meter per second. And calculate force fifth for cone is open bracket D equals to 45 degree or 135 degree close bracket. Fifth equal to PQV open bracket 1 plus cos D cos infinity which is, and close bracket equals to 1000 times 6.04 times 10 power of negative 5 times 1.2 times open bracket 1 plus cos open bracket 45 close bracket square and close bracket, and we got the answer is 0.12 Newton. So this is the result for flake plate. And for the sample 1, the flow rate is 1.28 times 10 power of negative 4, and the velocity is 2.54, and for the calculated force is 0.33, and for the measured force is 0.5. And this is for hemisphere result. The first sample flow rate is 9.26 times 0 power of negative 5, and for the velocity is 1.84, and for the calculated force is 0.34, and measured force is 0.5. So for the cone result, for sample 1 is flow rate 6.1 times 10 power of negative 5. For the velocity is 1.21 For the calculated force is 0.02, and for the measured force is 0.5. So for the discussions, and we have to compare of the four bodies. For sample 1, the loading given is 0.5 Newton, and calculated force for flat plate is 0.33, while for hemisphere is 0.34, and for cone is 0.02. So this is the graph of force measured versus calculated force for different deflectors. So yeah, this is the graph that I have been doing. So for the conclusion of this test is, as a conclusion, the calculated force is correlated with the measured force. Both of the force will have directly proportional reaction, and the difference between the theoretical value and the actual value may mainly due to human and servicing factors. Water valve not completely closed during collecting water is a parallax error that can affect the time taken for the water to be collected.